Hello again, and welcome back to Engineering Mechanics 1 Statics. We're working out tutorial sheet 4, and this is our question 4 work through on that problem sheet. Now, looking at this question, we have this kind of a frame that has a number of forces acting on it, and we are again asked to replace this with a single force coupled system at point A. So we need to find point A, which is down here. And what we want to do is to find out what is the equivalent force coupled system that acts at point A. Okay, what that does is gives us the effect of all these forces, what that would be acting at point A. So if we wish to analyze that, we would have an idea as to what kind of load is at that point. Okay, so the solution to this is pretty straightforward. We're following the same procedure that we did before. We got two steps. The first is the translational, and the second is the rotational. Okay, so the translational stuff concerns forces only. So things that cause translational effects, which are forces. And the second thing then is rotational effects, which are moments and couples. Okay, and in this problem we have no couples, so it's only moments that we will be taking. All right, so if I look at the translational effects, you can see that what I've done here is that I've decomposed each force acting on this frame into its I hat and j hat components. So this 5 kilonewton force I've replaced with 4 I hat minus 3 j hat. Okay, so you should see how I got that out for that one. We have the minus 2, just change colors here for this, go purple. The minus 2 j hat is this one here. And then I have, just change color again, we'll go green here for this force here. Okay, so I decomposed each of those into the I hat and j hat. I just lost the j hat off the edge of the sheet there, just by clipping. Okay, so these forces are simply moved down to the point. So we transfer all of them down to this point here, and we add those up. Okay, so we get there, 2.85 I hat minus 7.7 j hat, and that's all in kilonewtons. Okay, so that's the first part of the solution. And the second part then is to consider the rotational effects. So what we do now is we consider, well, what moment is caused by about point A by each component of those forces. So again, if we take the first force, it has the these two terms here. So we've got 4 as a magnitude. The distance here is 5, so we've got this force acting here. We have a distance of 5 from its line of action to point A. So that gives us 4 times 5. Using the right-hand rule, we decide the direction, and that gives us minus. So it's a clockwise rotation that it causes about point A. Then we've got the vertical component, which is 3. So again, it's coming down that way. So again, we just take the magnitude 3. The distance now is 4, and that is causing a anti-clockwise rotation. So that gives us a plus on this value here. Okay, and we repeat that process for the other two forces. So we got the 2 kilonewtons, okay, just acting in the negative y direction. Okay, this minus is not coming because it's in minus 2 j hat. The minus is coming from the direction of the rotation. So we just take the size of the force, which is 2. The distance is 1, and that causes a clockwise rotation, which according to our sign convention is negative, and that's why there's a minus on that. Okay, and we repeat that process then for the last force, the 3 kilonewton force, and we have the 5 and the 2 as the distances on that. So again, this component here is a distance of 5 from the point A, from its line of action. And for the vertical portion, you can see it's a distance of 2. Okay, so that's where the 5 and that 2 are coming from. And again, I'm assigning the directions. So plus is anti-clockwise and minus is clockwise. So we add all those up, we get minus 9.77 kilonewton meters as our answer for the rotational effects. So our overall answer then is, again, this is important to summarize, that our resultant force acting at A is the 2.85 I hat minus 7.77 j hat kilonewtons, and our rotational effects sum up to minus 9.77 k hat kilonewton meters. And you don't need to put the k out into this and be a bit pedantic, because I've written that as a vector form with the arrow overhead. As a 2D system, the moment directions are either plus k hat or minus k hat. So just putting a minus 9.77 kilometers is sufficient on that if you so wish. Or you can just say 9.77 and indicate that it's going in a clockwise direction. So again, just a swoop like that will suffice also. Okay, that concludes that question. I hope you found it useful, and we'll see you for the next question.